Hello everyone, this is Don with MecSoft Support, and today we're going to be taking a look at VisualCAMc, our plugin for Onshape, and we're going to be going through our Quick Start Guide. This is the video version of the Quick Start Guide document, and we'll show you how to take a look at that document as we go along. So what we're going to start with here is I'm logged in to our Onshape account, and once you get Onshape, once you get VisualCAMc app for Onshape, you'll see a VisualCAMc folder show up in your Teams folder, and you'll see VisualCAMc public. That is a team for our VisualCAMc users. So let's go ahead and start by showing you how to get the VisualCAMc app. Once you're logged into your Onshape account, just go up and select the App Store button, and that will take you to the Onshape App Store. And you'll see VisualCAMc is prominently displayed there at the top or near the top. If you don't see it, just go over here in the left and pick Cam, and you'll see VisualCAMc at the top. Just select the VisualCAMc tab and select a subscription version. You can do a monthly subscription or annual subscription. And once you get the subscription loaded, just go back to your Onshape account and go into your, we're going to do I'll show you how to load the VisualCAMc app in one of your documents. We're going to go through the Quick Start Guide document, and I'll show you that along the way. So let's go to the Teams folder, VisualCAMc Public, and we have a folder under here called Quick Start Guide. So if you open that up, you see that we have our Quick Start Guide part. We have a number of other parts that are examples that have been programmed for various machining operations here. And we also have the VisualCAMc Quick Start Guide PDF here, but I'm going to show you it within the document itself, which is a lot easier to get to. And we also have a question and answer guide, and we also have a reference guide. And I'll show you how to get a quick way to get to those also. So what we're going to do is we're going to start by making a copy of the Mill Quick Start Guide part. So we'll just right click on it and we'll copy the workspace, and we'll just leave it with the same name, and we'll just have copy on the end, and we'll pick OK. So this is going to create a copy of the source part for the Quick Start Guide. What you see here at the bottom, you see tabs, different tabs added here. Once you have your part loaded, and regardless of this part here, just any one of your Onshape parts, once you have the VisualCAMc app subscribed to, then just go to your Element tab and add your application and select VisualCAMc. And that will add a tab within your document for VisualCAMc that you can get started programming Toolpaths. So in this part, what we have is a plate that has holes on it. We have some contour along the edges, and we're going to do some facing, two-axis profiling, and we're going to do some drilling on some of these holes. Now, I mentioned an easy way to get to the Quick Start Guide document. If you see here, we have a tab called VisualCAMc QSG PDF. If you select that, it will display the Quick Start Guide document as a PDF file. So this is the same part that we're going to go through in the video. It may not be, in the video, it may not be exactly the same as the PDF document, but it's the same part, same toolpath, same procedures, basically. So what I was going to get at, what I was getting at a moment ago about access to the other reference guides. If you open the Quick Start Guide and scroll down a bit, you'll see access to this Quick Start Guide that you're looking at, a question and answer guide, and a reference guide, which is the complete VisualCAMc help system in a PDF document. And the quick start guide, the question and answer guide goes through a lot of questions about how you do certain things in VisualCAMc. So we're going to we're going to start. Also, you'll see that here that we have a VisualCAMc QSG start and a done tab. So this is our start part, and this is the part after it's already programmed. So let's go ahead and open our Start Part tab, and this will display the VisualCAMc interface. And you'll see that when you first load the tab for your document, it'll ask you what part do you want to use. And you can use the Part Studio part, which means that it is not only the model, but it's also any unconsumed sketches that you might have in the part. So you can get to any 2D geometry sketches within the Part Studio part. The subpart within this Part Studio top part is only the model. So for this guide, we only need the model, and we'll go ahead and load that. Okay, the next thing we're going to do is we're going to talk a little bit about the user interface of VisualCAMc. It has been progressively developing as the months go along, and since we've released this new plugin for Onshape this year, so you'll see new things being added on a regular basis. So to operate, if you're familiar, by the way, if you're familiar with MecSoft's desktop programs such as Visual Mill, VisualCAD-CAM, RhinoCam, VisualCAM for SolidWorks, or LibreCAM, you'll see some major similarities in how the workflow progresses. The toolpaths are very similar to our desktop application. A lot of the parameters are very similar. If you've used a MecSoft product previously, you'll be really easy getting started on VisualCAMc. So we have the main VisualCAMc toolbar at the top, where we have our home tab for loading and saving, preferences, accessing the online help. We have a mill tab where you can go through the process of setting up your part and programming it for your CNC machine. All you have to do is start from left to right and work your way across, and we'll show you the basics of that in just a moment. And we also have an Analyze tab that is really neat, and we're going to talk about that. Let's go ahead and go to the Home tab. And then on the left here, we have the machining browser. So all of your toolpath operations, when you create them, will be listed in under your machining job. And you also have a Tools tab and a Machining Job tab. So we have, on the Tools tab, we have the tools in the current document, which we don't have any yet. And we have tools in the current default library. We have a couple of tools in there. But we're going to be creating the tools we need for this document. So let's go ahead and go over to the Machining Job tab. And over here on the right is the main VisualCAMc display where you can look at your part. You can use the View heads-up toolbar here at the top for viewing. And you also have some toggles over here for displaying the stock, the part, the toolpath, the triads. So let's go ahead and get started in programming this part. We're going to deviate a little bit here from the PDF document, and we're going to show you the Analyze tab. You don't have to go back to the Onshape part document if you need to know how large holes are or how some certain depths. You have some Analyze tools here on this toolbar. For example, we're going to want to know how large these holes are. We're going to drill these 4 holes in the middle. So let's go ahead and select the Arc Diameter button, and we'll select this diameter, and it tells us that the diameter is 0.157. Those are the 4 holes. These ones all should be the same. So what we're going to do is we're going to go ahead and also analyze the depth so we know how deep to drill. So we'll just select the distance, and we'll select 2 points. And we see that the distance is 157 deep, and just making a note of that. So that's basically all we need to know so far for this part. So let's go ahead and continue on. We'll go to the Home tab. We're going to progress through our machining job on the Mill tab. And we'll start with the machine. The machine definition finds the orientation of your machine tool in relation to the part. By default, it's aligned with the world coordinate system in Onshape, and you can display that triad here. So you see you got a world system triad and you got a machine coordinate system triad. So you see that they're both aligned at the beginning. So we don't need to do anything under the machine. Now for our post, VisualCAMc comes with over 300 post processors that you can select from. We have a Haas post listed. If you have a different post, you can just select the load from defaults, pick the plus button here, and it'll list all of our 300 plus predefined post processors that you can select from. So let's go ahead and pick done. So we're going to select our Haas post and we're going to pick close. So you'll see that our post is set to Haas. For the stock, you'll see that we have no stock defined, and there's no stock shown around the part. So we're going to go up here under the stock menu, and we're going to pick part box stock. And what this does is this allows you to add some offsets to your part box for your stock dimensions. So you'll see that our part boundaries is approximately 1.5 inches by 1.5 inches by 157. So let's add a little bit on each side. And we'll add a little bit in the Z direction also. Let's change that to 0.01. Okay. So we have, if you go to the front view, you'll see that we have some stock on the sides. We got a little bit of stock on the top that we're going to machine down. Okay, so we have our stock definition. We'll pick save, and you'll see that our stock is defined under the machining job. Now let's talk a little bit about the setup. The setup is the machining orientation and coordinate system, fault machining coordinate system. So you have the machine tool coordinate system, and then you also have individual setup coordinate systems. And by default, there's one that's defined already, and it is aligned with the world coordinate system. Okay, and for this part, we're only going to machine from one side, so we don't need to add another setup right now. So we don't need to do anything under setup. We are going to create a work 0, and what this is going to do is this is the location on the stock that we're going to zero the machine out. And this is the origin and orientation that our toolpath coordinates will be measured from. So we'll go ahead and pick work 0. We're going to set the work 0 to the stock box, and we're going to move it to the highest Z on the top of the stock, and we're going to move it to southwest corner. So this is the corner we're going to zero the machine out on. So we'll pick save. So now as you see that we have a work 0 listed under our setup. And I mentioned these toggles here on the upper left corner of the main display. You can use them to toggle different elements on. You can toggle on and off your part. You can toggle on and off your stock, your toolpath if you have one created. We don't have one created yet, but you also toggle your triads, your machining orientation, and your world coordinate orientation. So let's go ahead and create a facing operation to machine the top face of this part. Let's go ahead and go over to the Tools tab and create a facing end mill. Okay, so we'll go ahead and pick in the Tools and Document tab at the top of the Tools tab. We're going to pick the Create tool. And when you don't have an operation already defined, you can create a tool while you're in an operation, but we have no operations defined yet. So it lists all of the possible tool definitions you can have across the top. If you're inside of an operation already, it'll only list the tools that are compatible with that operation type. So we're going to create a face mill, and we're going to set some dimensions for the face mill. We'll leave the holder set at 1. the holder length, length to 1.5, and the diameter, the tool diameter, we'll set that to 1, and we'll set the shank diameter to 0.5, and the shoulder length to 1.5, and the tool length to 2, and the flute length to 0.375. And the dimensions are located up here in the tool dialog image here. We also have a shoulder diameter, and we'll leave that set to 0.5 also. And over here on the right, you'll see a properties tab where we're going to set the material to high-speed steel and set the number of flutes, the tool number, address register, cut-com register, axial offset is 0. Coolant, we'll leave it set at none, and we'll leave it make a tool comment, my first tool. So this is the definition for the face mill, and for the name, let's call it face mill 1.00 diameter, and we'll pick save. So there is our face mill tool, and let's go back over to our machining job tab, and we'll create our first operation. We're going to face off the top of the part, so we'll go to the mill tab, and we'll select 2.5 axis, and we'll pick facing. We're going to go ahead and select our tool. We have our face mill selected by default, and we'll set our feeds and speeds. We'll leave these set to the default parameters for now. For your application, if you're going to cut this part out on your CNC machine, you can adjust these feeds and speeds appropriately. So for the clearance, this is where the tool will approach to and retract to whenever it needs to transfer or whenever it needs to do an approach and start cutting. So for the plane definition, we're going to leave it set to automatic and let VisualCAMc automatically determine a safe distance of the part to use as clearance. And for the cut transfer method, this is where's the tool going to go when it needs to move from one area to another. And we're going to have it set to clearance plane. And for our cut parameters, we're going to go ahead and set our tolerance to leave it set at 10 thousandths. And we'll set our stock to 0. And we'll leave cutter comp set to auto none. We're going to do an island offset cut. And we're going to do a mixed cut direction, and we're going to use a step over of 45% of the tool geometry. Now let's move to the cut levels tab. This tab is used to determine how deep we're going to cut in relation to the part. We'll leave the location of cut geometry set to at top, and we'll leave our total cut depth set to 0, and we'll go ahead and do our entry and exit. And this will determine how the tool will enter the part to begin cutting and how the tool exits the part. For entry, we're going to set it to lines and arcs, and we'll set the length to 1/4 of an inch. The angle will be 0, and the engage motion will be a radial motion, and we'll leave that set as 1/4 inch, and the engage ramp height, we'll leave that set to 0. So we're going to be entering from the side and clearing the facing operation. So let's go over to the advanced cut parameters tab, and we'll perform cut rounding, and we're going to go ahead and perform cut arc fitting, and we're going to set a fitting tolerance of 002. Generate the toolpath. And you'll see that we have a facing operation generated for the top of that part. Now, if you want to contain the facing operation better, in other words, if you want to contain it to a certain area, we can go ahead and select the outer perimeter of the part, and we'll make sure the location cut geometry, we'll change that to at bottom, so it'll be at the selected geometry is at the bottom of the cut. We're going to leave everything else set at 0 and we regenerate that. You'll see that we have a more contained toolpath to the shape of the part. And let's go ahead and save that. And you see that we have the facing operation listed under the work 0. So let's go ahead and simulate this so we can see what this facing operation looks like. So we'll just right click on facing and pick simulate. And that went pretty fast, so let's slow that down a little bit and let's pick play. So you see that we have our radial, our approach plunge here, and our approach, and then our radial engagement, and it follows the shape of the part. And then for exit, we're just retracting straight up off of the part. Okay, so let's go exit out the simulation tab. So you see now that the stock, the in-process stock, is shown on the part. There's our in-process stock right there. So we machined it down from our work 0 location down to the top of the part. Now, we want to machine the outer perimeter of this part. So let's go ahead and create a 2.5 axis profiling operation to machine that. And we'll call this outer perimeter. And for a tool, we're going to use an end mill, but we don't have one created. So we can go ahead and create one from the operation. So we just pick the create tool icon, and we're going to select end mill. And for the end mill name, we'll call that flat mill 1/8 inch diameter. And the holder diameter be 1, the holder length be 1.5, the shank diameter is 1/8 of an inch, the tool length is 2, shoulder length is 1.5, the flute length is 1, and the tool diameter is 125. And set that to high-speed steel. Tool number is 2, all these are 2, and we'll leave this set. We'll put a comment there of 1/8 inch diameter flat mill. Okay, so let's go ahead and pick save. So that you see we have another tool added to the tools list, and it is selected for this operation type. So we'll go to the feeds and speeds, and we'll leave those set to the default for now. Clearance plane, leave it set to default. And you'll see that the perimeter that we had selected from the previous operation is still selected. So we want to go ahead and leave that selected. Now, one option is for profiling, you don't have to select the top. You can select the bottom. So let's just show that. It's a little deviation from the PDF document, but we'll just show you that. We'll perimeter cut it to the bottom of the part. And for the cut parameters, we're going to go ahead and set a general tolerance of 1/1000. We'll leave a stock of 0. We're going to profile it right to the edge of the part. And we're going to use a mixed cut direction. And we'll go ahead and for the cut start side, we're going to determine using 3D model. So it'll know, don't cut this side, cut this side. This is the outside of the part. And then for a cut level parameters, we're going to go ahead and pick where's our geometry that we selected. It's at bottom. And for our cut depth, we're going to set this to total cut depth to 158. And we'll go ahead and leave a rough depth to 158. And we'll have a rough depth per cut to 0.05. So it's 50 thousandths per cut level down to 158. And we're also going to set our entry and exit. What we're going to do here is we're going to have a ramp motion that follows the perimeter of the part and ramps in. So we're going to do along a path, and for the angle we'll set it to 5 degrees, and for the ramp height we'll set it to 150 thousandths above the part, and we'll go ahead and do an overlap extension of 0.2. So this means that when it approaches and goes around, when it's done cutting, it'll go past that approach point, almost 0.2, to clear up any tool marks that you might have where you started cutting. So let's go ahead and do the exit parameters. We're going to do lines and arcs. The retract motion will be radial. Leave this set to 1/4 inch, the length to 1/4 inch. And for the advanced cut parameters, we're going to perform arc fitting, and we'll set this to 2 thousandths for the fitting tolerance. And let's go ahead and generate this toolpath and see what it looks like. Okay, so what you see here is we have a ramp motion coming in at 150 thousandths above the part at 5 degrees, and it's ramping around the perimeter of the part to the cut start point. So it will ramp in, go around, it'll do a mixed cut direction, so it'll keep coming around, and when it gets done it'll go 200 thousandths past the cut start point and retract. So let's go ahead and do a cut material simulation of this part. So we're going to save that. We'll right click on the operation and we'll pick simulate. So here's our ramp motion, and there's our start of cut. And there's our retract. Now, if you don't want to have a mixed cut direction, you can go ahead and exit the simulation, go into the outer perimeter operation. For the parameters, for the general parameters, you can do a climb or conventional cut. Let's use a climb cut, and let's generate that and see the difference. Okay, so here's our ramp motion. And let's go ahead and save that and simulate it again. And we'll speed that up a little bit once it gets started. So here's our 0.2 overlap to clean up any tool marks that might be left behind. So here you'll see that we have our outside perimeter cut, we have our facing cut. So let's go ahead and drill some holes, these 4 holes in the middle. So our hole diameters, we already checked a moment at the beginning, was 157 diameter by 157 deep. So let's go ahead and do some drilling, and we'll pick holes, drill, for just rename this drilling or drill 0.157 diameter 4 holes. And we'll go ahead and create a tool, and the tool is going to be a drill tool, and we'll call that drill 157 diameter. And the holder length was the same. The diameter will be 0.157. And our tool length will be 2, the shoulder length will be 1.5, flute length will be 1, and then the tool diameter will be 157. And set the material for the tool, and the tool numbers, number of flutes, etc. And we'll go ahead and turn the coolant on for the drilling operation for this tool, and we'll pick save. So now we have a drill tool in our document for this operation. It's listed right here and selected. So for the speeds, let's go ahead and slow this down a little bit. Let's have a spindle speed of say 190, and for the plunge, let's set that to 10, approach to 10, set all these to 10, the cut feed to 10, departure, retract and departure, set all these to 10. And for the coolant type, we'll leave that set to flood. Now for our clearance plane, we'll leave that set to the default automatic plane definition, and the cut transfer, we'll leave that set to clearance plane. Now for the drilling parameters, in drilling you have a number of different ways you can drill. You can drill a standard drill, a deep drill, countersink, brake chip. Deep and brake chip are very similar. Countersink drill, obviously we don't have any countersinks on the top. So we're going to go ahead and leave it set to standard drill, and we're going to set the drill depth to 0.158. And we're going to check this box to add the tool tip to the depth, which means it'll extend, the diameter of the tool will extend to the bottom diameter of the hole, and the tool tip will extend below that to make sure that we get a good through hole. And for the location of our geometry, now you see that the geometry was selected from the previous operation. Just to unselect, pick the space bar, and we're going to select these 4 holes to drill. And where those 4 holes located at that we selected, they're located at the top of our cut. And we'll also leave all of these set to the defaults. And for sorting, well, let's leave the sorting off, and we'll show you the difference between sorting and not sorting. So let's generate these. So here's our toolpath for our 4 drilling holes. We're going to drill these 4 holes. The sorting operations, you can do a minimum distance, or you can do a directional sort, and you can give it an angle. If a lot of holes, you can tell it the direction you want to start in one corner and go, from one corner to the upper corner, or direction, however you want to locate and drill these holes. So we have a directional sort, and that changed the cut pattern. If you want to do a minimum distance sort, here's the cut pattern for that. We'll leave it set to that. So we're going to pick save, and then we're going to simulate this. So let's right click, pick simulate, and let's slow this way down, and we'll just step through this. You'll see that the tool tip is extended past the hole diameter. Okay, so now that we got all 3 operations done, we got a facing operation, we have a outer perimeter profiling operation, and we have a drilling operation. We can also simulate the entire setup. So let's go ahead and do that. Okay, once we got it simulated, we'll go ahead and pick exit. And if you want to know some estimated machining time for each of the operations, you can just hover over an operation, and the tooltip will tell you the machining time, 24 seconds for the facing, 33 seconds for the outer perimeter, and then 2 seconds for the drilling. And then for the entire setup, approximately 1 minute to machine this part. So let's go ahead and also post out our G code. So we'll go ahead and you can post out one operation at a time, or you can post the entire setup. So let's select the entire setup, and we'll right-click and pick Post Process. And you'll see that the G-code file was downloaded to your computer and listed here. So let's go ahead and open that. And you'll see here the G-code for the Haas machine. We have our setup, our work 0, the facing operation, the tool, first tool comment, and then we have the tool information. And then we're going to go ahead, we're going to move on down, and you'll see that we have our outer perimeter, our tool comment, our tool information, and then we go on down to our drilling operation. So, and for drilling, the drilling, tapping, boring, or reforming, these are all canned cycles. Your CNC machine will need to be able to handle canned cycles for drilling. So there's our G-code. And another thing that I want to show you before I leave is some preferences that you can set, CAM preferences. So let's go to the Home tab and we'll pick Preferences. Here you can set all the different colors for your general colors, your tool, how the tool looks, the colors for the tool, the stock colors, the cut stock colors, all of the toolpath, individual toolpath colors. And for toolpath output parameters, you can, if your CNC machine cannot handle arc motions, you can output all as linear segments. And for drilling, I mentioned a moment ago, if your CNC machine cannot handle canned cycles for drilling, you can output the drilling operations as linear motions. So each of the linear XYZ coordinate motions required to perform that drilling operation will be posted to the G-code. And then we have some posting preferences, or how you're going to name the post files when you post, and then some general system preferences for auto-saving, etc. So that's it for this Quick Start Guide video. If you have any more questions or need any more help, you can select the Help button here and go to our online help system. For VisualCAMc, it has all kinds of topics, shows you how to do things, anything that you need to do in VisualCAMc. Also, if you need help on an operation dialog, just pick the Help button and it'll show you the information for that operation. Okay, that's it for now. And also, you can contact us at support@mecsoft.com. If you have questions, or if you get stuck, if you need any additional information, just give us a call and we'll be glad to help you out. Take care and enjoy your VisualCAMc.